My name is Jason Edens, and I work for a nonprofit organization called the Rural Renewable Energy Alliance. And our nonprofit is dedicated to making renewable energy accessible to people of all income levels. And the way we do that primarily is through our solar assistance program, which is solar heat for low-income households, households that qualify for fuel assistance. There are two systems on the home. There's a solar forced air system, which basically heats the household air. So you can have a very cold winter day. It can be 0 degrees or -20, but if the sun is shining, you're going to get a tremendous amount of heat out of the system. In fact, this particular system will provide 6,500 BTUs per hour when it's 0 degrees Fahrenheit. So it's very effective. There's no pollution, there's no emissions whatsoever. And then the other system on this home is a small standalone solar electric system, a photovoltaic system. It's going to be about 250 watts, and it'll provide all of their electrical needs. So these are the two solar electric panels for their home. And interestingly, these two panels are made by British Petroleum. So a lot of the petroleum companies are well aware of the fact that we're reaching peak oil, and henceforth there'll be less and less oil production across the globe. But essentially, these guys produce DC electricity, and it is then, of course, sent into the home. And if they have DC loads in the home, they can use the DC power directly, which is efficient because you don't have to convert it into AC. But the actual production of electricity is simpler than one might think. It looks, almost magical. How does this happen? How is this able to produce electricity from the sun? But the metals that are used to actually make the cells are photoreactive, and the electrons in the outer shells of the atoms are excited when exposed to the sun, and they're basically released, and as that happens, you basically capture that release into a circuit. We have installed the solar heating system, which is on the south side of the house. It's not quite done yet, but we're getting there. It's a really simple system. There's basically a black metal with a special paint on it. As it passes across that absorber plate, the air is heated, and it can heat up to 20 degrees Celsius as it moves across that panel. And then it re-enters the house, and this air is circulated over the course of the day. And a system of this size will probably provide anywhere from 25 to 60% of their winter heating needs, which is very substantial, especially with soaring fuel costs. This is a clean and inexpensive way to accomplish the heating needs. And we're also working on a solar electric system. This is the balance of system of the solar electric system.
Here is the main shut-off for everything. On. This will be the charge control. It adjusts how much of the solar panels goes into the batteries, which is going to be in this box right here. And this is just a junction where all the wires get together, and here's a regular panel just like in everybody's house, only it's going to be DC instead of AC. DC is direct current, like in a flashlight or a car battery, and AC is alternating current, like a blow dryer. And this is the inverter. If they do want a little AC, they can plug in regular appliances into there.
There's basically two different types of solar systems. There's a solar electric system and a solar heat system. And then from those two divisions, you can further divide. A solar electric system is usually one of two types. It's either a battery-based standalone system like this system, or it's a grid interactive system, which is where there's no batteries, and all of the power that you produce is sent directly into the grid after you've used whatever you're using at the time. And there's lots of state rebates right now for grid interactive systems. In fact, the state will give you $2,000 per kilowatt that you install. And a lot of the utilities are matching that. Minnesota Power matches that, and a lot of the co-ops are matching that as well now. So there's a tremendous amount of incentives right now for grid interactive solar systems. And there are also some new federal income tax incentives for solar electric and solar heat systems. Now, as far as solar heating systems are concerned, there's a hot air system like this one, which is a very simple, low-cost system. And then there's also a solar hot water system, where rather than air flowing through the collectors, you actually have a heat transfer fluid. And you can heat your domestic water. You can also do space heating. A lot of people are tying these systems into in-floor heat systems, so you can store the heat in the slab. So there's many ways to employ these systems, depending on your site and that type of thing.
And we basically sell renewable energy systems to homes and businesses, and we do so on a sliding income scale. And we sell these systems to help us finance our solar assistance program. Because every year the state of Minnesota spends literally tens of millions of dollars on fuel assistance. And fuel assistance simply pays a low-income family's heating bills, families who struggle to pay for their heat essentially. The state will step in and pay their heating bills. And it's a very expensive Band-Aid, but it doesn't provide a long-term solution. Whereas our solar assistance program actually does, because it gives them the equipment to provide for their own heat. It empowers the families, it provides self-reliance, and it does all those things with a clean technology rather than a fuel subsidy, which is essentially what fuel assistance is.
I said earlier, we are a nonprofit, and our primary program is one of charity, and so we're always seeking people to help support our work. And by this time next year, we will have an additional 20 solar assistance jobs done, and they'll be all across central and north central Minnesota. And we hope to do this all across the Midwest too. I will say that we're not yet adequately funded. The people who are on payroll receive a very, very meager stipend. We get a lot of funding from the Initiative Foundation. We get funding from the University of Minnesota Central Region Partnership. We've also worked with the Clean Energy Resource Teams. They've been very generous as well. But we, as I said earlier, we're always continuing to look for people to help support our work. It's very important work. And using a clean technology to help the lower income families who are struggling to heat their homes is a very appropriate technology.